Alright, so starting on the samsclass.info page, you click this ARM assembly and exploitation link, and that gets you to the exploit development stuff. And the first one I want to do is a Linux buffer overflows. We're going to do buffer overflows on Intel and then on ARM. I think it's easier to understand it on the older system first. So there's a couple libraries to install, which I've already installed on this Debian machine I'm using, and then we can create a vulnerable program. I may already have that on here, I think. ed201.c. I do, okay. Alright. So I'm going to shove the instructions to the side so I can use the screen for... Alright. So, I'm going to make a program with a buffer overflow vulnerability here. And here it is. Alright. So you bring in some libraries, and then you make a subroutine for the buffer overflow to be in. It's best not to put the buffer overflow in the main routine. It's hard to exploit those. So here in the main routine, I asked the user, what is your name? And I put it in a variable with enough room for 200 characters. And then I call this BO subroutine with two variables, the name that I'm passing in and another string that includes the Linux command date. Then in here, in the subroutine, I define two variables that only have room for 40 characters and copy the command that's passed in into there. So this command might be up to 200 characters long, but I shove it in something that only has room for 40. And I have two variables here, one for command and one for a name. And what's being passed in are those parameters. There's the name and the command. So if your name is longer than 40 characters, it will leak out of the name variable into the command variable. Now this is not the most famous kind of buffer overflow, which we'll get to later, where you overflow the control structures and gain control of the instruction pointer. But this kind of buffer overflow is actually much harder to prevent, where you leak out of one variable into another variable. Anyway, I'm going to compile that program as 32-bit code, just to make it easier to analyze later. And then if you run it, buff32, and you give it a name like a short name, then it just says goodbye Sam and executes the command date, because the name and the string containing the command did not collide. But if you put in a longer name, there's 10 characters, so there's 10, 20, 30, 40, and now I put in ls. Then your name is now 40 characters and ls, but the second variable command has turned into ls, and now it executes the command ls instead of executing the original command date. So this is a buffer overflow from one variable into another, creating command execution vulnerability. And so if we try to do an ls minus l, for example, if I take this and input it, space minus L, then it only executes the ls because the space is interpreted by C as the end of the first string. So if you want to execute an ls minus L, you have to trick it somehow. One technique you can use is to backslash to tell it that the next character should be ignored, but that doesn't work in these conditions. And I think another way that sometimes works is to encase the whole thing in quotation marks. Under different circumstances, different ones like this will work. In this case it failed. The thing that works in this case, I think, is the IFS. This is a character, an environment variable called the interfield separator, which serves as a space, and now it actually understands this command as ls space minus L and gives me the long list. And these are techniques you use to sneak in a character that is misunderstood by the processing. And this is a big issue in all buffer overflow exploits. You try to sneak in something that's unexpected into a field like a name or something, and some characters that you want to stick in are going to be misunderstood at the other end. Anyway, There are some flags defined here where you get to exploit this thing with the command injection vulnerability and find some flags, one of them running on the server. So that's the simplest case of a buffer overflow. And I'm going to stop this video